even examined on that part. Yeah. So let me move to question number 9. Okay. Question number 9, we have a rod, and it's made up of two materials, so row 1 and row 2, and each one of them has length 1, length 2, and they have the same cross-sectional area. He wants what is the resistance between the two ends of the rod. So basically he wants R equivalent. And if you consider this as resistances R1 and R2, so if this is R1 and R2, simply the equivalent resistance will be R1 plus R2. And each one of them is simply R is equal to rho L divided by A. Okay, L divided by A. L in each one of them is L1, L2. The area is the same and rho is different. Okay, so you just have to the following. I mean, you just have rho 1 L1 divided by A is equal plus rho 2 L2 divided by A, and then you combine the area. In this case, because it's square, the area is simply D squared. That's it. That's all you have to do, and I don't think there is any I don't think there is any tricks here or anything that you have to worry about. Okay, let me move to question number 10. Okay, so question number 10 says that what is the equivalent resistance of the network shown? Again, we have to be careful with this because they said there will be questions about like this in the exam. So let me start from the far, and then I go this way. So I combine these as series. So this will be will give me 30 plus 20 plus 30. So 60 plus, that's 80. Right? And then this is 80 ohms. Then I have something like this, 80 ohms, and it's combined with this guy. And then it's, so 80 and 10. This is 10, this is 80. So I combine now these two in parallel. So 1R equivalent is equal to 1 over 10 plus 1 over 80. I combine these, and then I'm going to end up with a circuit that is like this, which is series. Then I combine, so there's 10, and this R equivalent here. Okay. And then this one is 20 ohms, and then I combine these guys as series, and that's the end of the again, it's a very straightforward question. Okay. The next question is that you have when a thin copper wire of length that much is connected between two terminals of the battery, a current flows this produced. What is the diameter of the wire? I think this is, again, is a very straightforward question. You have something like this, where the length is 178 meters, and the current flowing through this conductor is equal to 2 amps. Okay? And it's a copper, so we have the resistivity in copper. In order to find the, what does he want? He wants, what's the current? Okay, the resistivity, what is the diameter of the wire? So he wants the diameter of the wire, which I can find from the area. So since he gave me the current, okay, and I can calculate the resistor or the resistance, and he gave me V. So from here I can find R. V is equal to 1.2 volt, and I is equal to 2, so I can calculate R. And then I come in here and I put this value here, and this is given, and L, and this one is what is pi R square, and then from here I calculate R, and then D is equal to 2R, and that's the answer here. So just have to put in the numbers and calculate that. Okay, that's question number 12. Let me do question number 13, and then just to make these videos short, then I'll break or at least move on to video number 2. So this question is again a little bit, it's not tricky, but you just have to know what you're doing. So we have this sheet, it's 2 millimeter thickness. So the thickness here is 2 millimeters. Okay, 2 millimeters thick, and has a surface area of 8. The dimension, this is 8, and that's 24. And when we made a cylinder of it, the conductor, that's in the shape of a cylinder, as you can see here in the question. What does he want? He wants, what's the resistance between both ends? So definitely I have to use this. I have to use the resistance is equal, R is equal rho of this material, L divided by A. This is copper, right? A copper sheet. So rho of copper, the resistivity of copper is given. And L is given, that's the length of the conductor. The only thing that I need to worry about is the area. The area, if you look at from the top view, you're going to see something like this. You have an area in and an area out. This is the area in, this is the area out. So your area will be area in minus area will be area in minus area out. Or the inner area, or the outer area, sorry, the outer area minus the inner area. Outer minus area inner. And the inner area will be simply pi r square, and this case r is 8 because it's going to be like this, right? So the area will be the r in this case, my r will be simply because this is 2 pi r. 2 pi r is equal to 8, right? Because that's so that means I can, from here I can find r is simply 8 divided by 2 pi. That's my r in. And to get my r out will be simply r in, the one I got, plus the 2 millimeters. And then my r, it's not 8, sorry. It's not 8. It's this value here plus 2 millimeters. Okay, I think you see how I got the areas in. So then you divide. You subtract the area out. No, this is not 8 millimeters. This is the 2 pi r. 2 pi r is equal to 8. Please be careful. That's 2 pi r is equal to 8, and from there you can get the n. And once you get the inner radius, then you add to it this little bit, 2 millimeters, and then that will be your outer area. And then you calculate your outer area, and then you subtract them from each other. You get the area that you should put in here, and then the question is solved. Okay, that's it. So let me stop here, and then we'll continue with the remaining problems in the next video.